All right, we're going to continue on OABuilder, and on this session we're going to talk about the editors. We talked about the actual desktop area, work area, where the model's being displayed. We talked about the code generators. Let's see if there's anything else here we're missing. We'll kind of go through the whole thing later as far as actively modeling and changing a model and stuff like that, and a couple other sessions. In this one we're going to go ahead and look at the editors. One of the things I mentioned before is that the editing process or building out your models has been automated so that once we say we want new something or add something like a reference to another object, pretty much defaults very closely to exactly what we want, and then we fine-tune it from there. So there's lots of places, as you can see here from these editors, that we can go into. So I'm going to give an overview of all these in this session, and as we start using them and building them, you kind of see how it all fits together. I'll go ahead and just use this employee object because that makes sense. Basically, within the editor for the object itself, we have information about it. The information that we need to capture is a couple things. One is the object structure itself, the information we want to keep, how it relates to the database, how it relates to the UI, and UI meaning, you know, how do you display it, how do you edit it, how do you search for it, how do you again display it again in a listing, those combinations, how you display it in a report, protection type level stuff that goes with that, lookup, how does it look it up, you know, does it do a search, does it have a drop down list, you know, that type of information. So as we go through we'll see how that's defined. The other area is how it communicates to the server. Almost all of our objects are set up to be synchronized with the server, and there's a communication layer that's automatically handled for us, and it gives us more than a client-server type functionality. It gives us a synchronized application, a real-time application, so everything acts as one server. And that's kind of the one of the things with these applications is to set it up so that you can have many applications running, or computers running the same application, and they're all in sync, so to speak, even though they're doing different things, and some of them are doing the same thing, and you could automatically see how it all stays in sync. And it's all built in, and it's all part of the structure, and very little overhead, and it buys us a lot of functionality and a lot of power in what we can do in our applications. So the model itself, we define information about that. We won't get into details here. There's within the model we can define what's called filters. So there could be ways that we want to filter out the information so we can have a subset of it, and those filters could be in this case, give me everybody who has a next anniversary, you know, and that information, and then what's the code behind that, and if there's a query that we can use to prefetch all those from the database. Once it's prefetched from the database, that list is automatically kept up to date. So if we go in here and get everybody whose next birthday is in the next week, we could define this in here as far as a filter, and we could say 7 days. When the application starts up, it would know to go find all those based on the 7 days, and it knows the month, day, how to get that from the structure for the date structures and stuff. Bring that up. As the application's running, something changes, employee gets added, birthday gets changed, something like that, we'll automatically update the list. So as an application developer, I don't have to worry about that. I don't have to requery and all that kind of stuff. It's part of this whole reactive modeling, so it knows that. And again, based on this filter, it could do that. That doesn't keep me from having an application or code in my application that I can go select certain criteria, and I don't need it updated. I don't need this whole real-time thing going on. I just need to get this data. I want to see all the birth dates, or I want to see something else based on criteria, and I'm going to do something with that. So this isn't the only way that you can do stuff like that. This is an automated way when you need automated things. And again, in an application that's always running, a good example, next birthday is probably, you know, it's a useful feature, but you could have that running in its own process, doing its own query, and not have to be up to date in real time and in sync with everything else. You could just do that in a background process or something. Another thing might be open orders or problem orders. There's something's going wrong, and you want the UI to automatically get access to that and color code it so that it automatically gets a user's attention or goes into a log file in a certain way. All that type of stuff can be in this reactive modeling type framework type stuff. So you have your objects. You have a way of building these filters. The filters then can be told what information is needed for that filtering, and then there's a code generation which will help you actually generate the code that goes with that, that defines that. Also within the object itself, there's information about the user interface, and I'm just briefly go through here. Here's the different areas that we need for our user interface. What we need to see in the edit panel, what we want to see in an edit table, so an editable table listing of this, what we want to be searched on, what we want to show up in the search table, if there's a search tree. In other words, can I get to this object by accessing a tree type structure, kind of drilling through, so to speak, from someplace else? And this says yes. If from the company I can get to the programs, I can get to the locations, I can get to the employees, I can drill down into them. Another part that we didn't mention on the objects is they could be recursive. This line here is showing a recursive relationship. Recursive means employees can have employees, or the object has other objects under it. And we can set that relationship up to say it can go many levels, again, recursive. And so whenever we have that, it's set up so that it will automatically know how to get that data. And again, it uses this information, generates the application, generates the UI. In this case, in our UI, we would see a tree that allows you to actually find an employee through doing that. It also, since we're put in our search, it's going to build a search criteria based on this. We also have these filters. So, and on each filter, we could tell it, do we want this to be part of the application's application itself, to show up in our at a root level in our application, and it would automatically have that showing up. In this case, we don't really need that. So on the object, there's that information. We talked about the user interface. We can build in the help. This will generate a help system that's context sensitive help and stuff like that for that user manual. And again, this is basically taking the requirements that we use to build the model, and in turn we can then take the information in there and generate it to create basically a requirements document and a help system from that. The properties for this object are what we see here in bold, and each one of these properties has information about it. And again, we put these in and it pretty much defaults pretty close to exactly what we want. Usually if it's a string, we'll have to define the lengths and stuff like that, but across the board it will pretty much lay it out the way that we want. There's other information that goes as far as if there's another place to get this data from, enabled visibility. This is permissioning type information. There's information, different flags that we can set up that that further define this type of data. There's a help. There's if we want to customize the code. Basically, it's a getter setter type code, and that's about it especially for these. Name values, if it's a enum type information. So if it is I don't know if I have any right here off the top of my head. As we get into the application, we'll see some of these, but this could be a list. It could be a property that's an integer, and a 0 means it's open, a 1 means it's in process, 2 means it's closed, 3 means it was rejected, or stuff like that. Also, we can further define, and in this case we would generate the template code that would be used for rendering, editing type code. And what this will do is, this is the code that we want it to have it automatically put into the UI, as opposed to default what it does. And so we can customize the rendering. We could automatically draw a box around it and stuff like that. It's custom borders and stuff like that. So calculate properties. We talked about filters, how filters can basically be set up to tell it how it filters information, what information it needs to know to be able to filter the information, and then if something changes with that, it knows to refilter whatever is affected based on that. Calculate properties are very similar, or use a similar type of functionality. This is very similar to what I mentioned earlier about a spreadsheet having formulas, and these could be different formulas, and these get very powerful because they could use your whole object model. So based on your references, you could use something, these property paths or properties. So in this case, I can say we're on employee still, and does employee has open award. We want to know if this employee has an award that's still open, in other words, that they haven't claimed yet. Well, we can go in here and we could put in the information that determines if that's true or false, because we set this up to be Boolean. Again, it could return anything we want. And if it used other information, we could do that. If you notice, it has employee awards dot created, dot balance, dot product. This information says that from this object, go to this object, or in this case, this is a reference to many of these, and check this value, check this value, check this value. If you notice, this one here is in italics, balance, because balance itself is another calculated property. Well, if something changes that affects balance, balance automatically will get updated. Well, if in what we're saying here, if balance gets changed, we need to go ahead and recalculate our open award. So it has this chain reaction type thing. So within this reactive model, as one thing gets changed, you can plug stuff together and say, I want to know if this gets changed because this needs to affect this. The calculate properties then have the code that actually does the calculation, and a lot of times what we'll do is we'll move this code out to a delegate object. So we will put that in there. There's a generator for this also that will generate the skeleton for this, and then we can fine tune that formula. And there's also some pop-up help and stuff like that. If we want to build in a query based on querying this data from the database when it comes up live, if we wanted to do that. But for the most part, these objects, an employee already has its data itself. It knows how to get to its other reference data, which is what's being used in this this calculate property we looked at. So we don't even have to generate. There's nothing there that we have to worry about. This goes back to if we want to generate custom code, and this is most of the time, don't use it very often, it's for rendering components like within a grid table listing, stuff like that. A link, and we'll pull up a link here, is an employee has, in this case, many addresses. So if I mouse over this, bottom left down here, I can see what that is. So I can go back to this link. We have different relationships. All of them are covered. One to many, many to many, many to one, blah, 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 all the way through. And again, as we change this, it pretty much defaults all of our information pretty close to what we wanted. So that's a pretty automated thing. As we create these links, and again, as we show some modeling and stuff like that, we'll show how these links are created and stuff. Bottom line is back to the model being able to create 100% of it. That's still the fact. Even, you know, our relationships obviously are a big part of that. And if you think about it, there's lot more functionality than this just saying that this object has a reference to another object and what type it is. There's additional information like using recursive stuff, using dependent relationships, using a relationship that doesn't exist unless another relationship has been fulfilled. That type of stuff makes this really solid as far as handling a lot of the different scenarios and eliminating any of that type of code that you'd need to write. But what's nice about it is there's a small amount of those different scenarios that make it pretty much completely handle all the different things that you run into. So those links, as we go through, there's information that's turned on and off and customized for whatever the reference is that we're talking about and how we want to deal with that. Again, as we get into some modeling examples, we'll show those different scenarios. But if I just wanted a one-to-many, employee has addresses, I also want to go in there. What I customize here is I would say the employee is the owner of those addresses. In other words, this is an aggregate type of relationship. This case, employee addresses doesn't necessarily have to be, but it's a good fit for that. but there's other areas, other relationships, like if we look at this, what's called an E-card, an employee has an E-card. If I look at the relationship between the employee and the E-card, I also know that an employee E-card is based on an employee and an E-card. That's what this is telling me here. So this relationship, an employee has many E-cards, is also saying that to create a new employee card, you go pick your E-card first, and then it will automatically create this object for you, so you have that. So again, it uses that information when it generates the UI application. It knows how to create that. So instead of just being a CRUD where you got to look up the E-card, it says no, it's a lot smarter than that. It says, do you want to create a new, do you want to send an E-card to this employee? It will then let you pick the E-card, and then it will then allow you to fill out all the information about the employee card, which basically then lets you put a message on it and all this other kind of custom stuff. The other interesting part about that is it doesn't just show you all the E-cards in the system. It can, if that's what you want to. In this case, the requirement for this application, whatever company this employee is from, they pick a subset of these E-cards. So if I look at this line here, this subset of E-cards is employee has a list of E-cards that they can get pick from. So this line being dotted means that it's custom. And what that basically means, it's a calculated reference. In this case, for this application, is the list of E-cards that this employee is allowed to pick from is coming from another list that gets filtered, that then is the subset that this employee gets to use whenever they want to pick one. What's nice about this, it comes right back to our model should be able to contain 100% of our requirements. And this is just another scenario, and there's other things, especially in this application, that shows how we can take a requirement and say, oh, how are we going to fit this into our model that's supposed to be able to do everything for us, and it allows us to do that kind of stuff. The UI perspective, application programming perspective, we don't have to think about it then. Whenever I'm an application and I'm creating the part of the application or customizing or doing whatever I need to do to allow the employee to create an E-card and send it to somebody, it's already built in here. I can go to the employee object, and it already has a reference that has a collection of these E-cards that I can then display to the user. They pick one, and it automatically allows them to fill out the additional information. The client application, the UI application that gets created off this model, that's exactly how it works. The web application, again, our web application, we have a designer designing this thing out, and maybe a different view and a different type of functionality, access level and stuff like that for a certain type of user or whatever. When we go in and actually plug this into his page, where he put in his page, here's where here's where it's going to display the images for all the different E-cards they can pick. All we have to do is go in there and we pick this. We have a component that will take that list and get the images, put them on that page for us, dynamically changing out what the web designer put in there as far as his mocked up data and bringing in the dynamic data and stuff. Methods, just custom methods that basically are mostly pertaining to working on this object. So I'm on this E-card now, or where am I? Yeah, I'm on the E-card, and the E-card, we have a method in here that says save as a sample PDF. Basically means we want to pull up an E-card and save it as a PDF so we can send it to a customer and say, do you like this E-card? Do you want this in your program? That type of thing. So this allows us to do that. It also sets up, so in our UI application, do we want to make this as a command? And just by checking this, it will automatically do that. Now our UI application has that information. The code itself, our OA component in our OA, I guess, component in libraries have lots of routines to deal with all these different types of things, components and functionality, images, in this case PDF. So we can call out to some code that we put in our delegate that actually lets them, send it out and send it as a PDF and create it and everything. Index, for the most part, as we're going through an application, we can say that something's indexed. So this would show us that. If we want to create something more of a compound index or reverse, it's ordering and stuff like that, we can go in here and create a new one. Don't have to do it too much. Symbology is that would show here, we can show that employee code has a little lightning bolt type thing beside it, so that shows its index. So by looking at the model, you know, you can start it's easy to tell what's going on. One of the things we have to do is make sure our strings were long enough, you know, and stuff like that. So a lot of times I'll just kind of go through these and check these. Color coding these objects is really just how it's just organization. We can color code them any way we want. We'll get more into that as far as the features of kind of modeling and laying stuff out and how we manage the model itself, because again, as your model grows, you know, you have some stuff that's already done, pretty much in place. Then you have some stuff that's new, it's in the works and stuff like that. So we'll use some color coding to help with that. I think that covers it for the model, and we'll end this session now.